This is Katie Bowman's AP problem number 5. So initially in the problem we're given a balanced equation, and then the problem reads, Cl2 can be generated in a laboratory by reacting potassium permanganate with an acidified solution of sodium chloride. The net ionic equation for the reaction is given above. So part A asks us, or tells us, a 25 milliliter sample of 0.25 molar NaCl reacts completely with excess KMnO4. The Cl2 produced is dried and stored in a sealed container at 22 degrees Celsius. The pressure of the Cl2 in the container is 0.950. And then part 1 asks us to calculate the number of moles in Cl- aqueous present before any reaction occurs. So what I did for part 1 was I took the 0.250 molar of NaCl, and I knew that molarity is moles over liter, so we're looking for moles, so that's our x, our unknown, and then our liters is 0.025, and they give us the milliliters in the equation, so I just converted it to liters by dividing it by 1,000. And then when I multiply 0.250 and 0.025, I get 0.00625 moles of NaCl. And we need to turn it into Cl-. So what I did is, knowing that it's an acidified solution, it's probably going to be a decomposition reaction. So when you take NaCl and you pull it apart, you get Na plus and Cl minus. And when it's balanced, you get 1, 1, 1. So I did molar-mole stoichiometry, and I did 0.00625 moles of NaCl, and then I put 1 mole of Cl minus on top, and then 1 mole of NaCl on the bottom to cancel out these units. And since it's 1 to 1, you get the same answer. It's 0.00625 moles of Cl minus. So that's our answer for part 1. And then part 2 asks us to calculate the volume of liters in the Cl2 in the sealed container. So because they give us, we need to find it in liters, so we can't do what we did last time. We have to find a new way. And they give us the temperature in Celsius, we have liters, we have pressure, so we're looking, or no, we don't have liters because we're looking for volume, but we have pressure, we have our R, which is our constant, we have a pressure, and then we can find the moles using multiple stoichiometry. So what I did is I took the 0.00625 moles of Cl minus that I got from the part above, and I did multiple stoichiometry using the balanced equation that it gave us above. So you see there's 4 moles of Cl minus, and then there's 2 moles of Cl2. So I put 4 moles of Cl minus on the bottom, 2 moles of Cl2 on top, and then I got 0.00313 moles of Cl2. So then I did PV equals nRT, and I used 0.95 ATM, which they give us. We're looking for liters, 0.00313, which I just found above, our 0.0821 constant, and then 295 Kelvin, which I found by adding 22 degrees Celsius to 273 degrees, or 273 Kelvin, and that gives us 0.0798 liters of Cl2. So that's the end of part A. And then part B asks, using the information in the table, determine the order of the reaction with respect to each of the following. Justify your answer. So it gives us this table with like its experimental data, and it gives us Cl minus, MnO4 minus, and H plus, and then the rate of disappearance for the MnO4 in molarity per seconds minus. What I did, I started with Cl minus, and I used the rate, rate equals K, concentration A. So I did rate equals 2.03 times 10 to the negative 7 over 2.25 times 10 to the negative 8, which is the rates for 2 of the trials. And then I used the concentrations that it gave me. So K to the 0.0312 to the X times 0.004 to the y, and then on the bottom I put k times 0.0104 to the x times 0.004 to the y, and the k's cross out and the 0.004 crosses out because they're the same. So now we're just dealing with this and this. So this gets us to about 9, and then this gets us to about 3. So our x is going to equal 2. So that's going to be our exponent when we make our rate law. So the next one was MnO4, and I did the same thing. I used 2 of the rates that we were given. I brought it over here. I used the concentrations, and then in this one, the k's will cross out, and then the x's will cross out, and we'll be left with 0.004 to the y and 0.002 to the y, and that gives us 2 equals 2 to the y, so y equals 1, so that will be our exponent for MnO4 for the rate law. So that brings us to part C, which asks, the reaction is known to be third order with respect to H+, and that tells us we're going to need to include H+ in our rate law. Using this information in your answers to part B above, complete both the following. Write the rate law for the reaction. So what we did in part B is going to help us form our rate law. So our rate law is going to be rate equals K times Cl minus to the second, MnO4 to the first, and then H plus to the third. Since it's respect to H plus, we got to include that into our rate law. And then part 2 asks us to calculate the value of the rate constant K for the reaction, including appropriate units. So what we're going to do is we're going to plug trial 1 into our equation, or our rate law that we made up here. So we're going to use the rate of 2.25 times 10 to the negative 8 equals K times 0.0104 to the second times 0.004 times 3 to the third, and when we multiply these all together and then we'll divide it over to get K by itself, that gives us K is equal to 1.93 times 10 to the negative 3 m negative 5 s negative 1, and we get these units because this is m, or molarity, times second to the negative 1, and then these, when they're added up, is 6. So if you move that over and you subtract it, 1 minus 6 is negative 5, and then you leave the s to the negative 1, it just stays there, and so that's how you get your units for that. And then the last part asks us, rats. The last part asks us, is it likely that the reaction occurs in a single elementary step? Justify your answer. I said, no, it is unlikely because all of the reactants would have to collide at once for the whole reaction to occur. So according to collision theory, for a reaction to occur, the reactants have to have the right orientation, the right, like enough energy, and things like catalysts help them and stuff like that. So to assume that all 3 of these collide at one time in one step perfectly is very, very unlikely. So that's why I said no, it is probably not going to happen in one little step. Alright, so that's the end of my AP problem.